All right, we now return after some technical difficulties. Hopefully things go better. We were looking at number 3 when the last video sort of cut out, and I'd asked Michael this question. On number 3, we've got an 11, plus we're adding a negative 11. And we add those two things together. Those two numbers are called additive inverses, a positive 11 plus a negative 11. And class, when you add additive inverses, they will always cancel. They'll cancel to give you 0.
Yeah.
So without even doing a number line, we know number 3 is going to be 0. What about number 4, class? 0. Because again, they are additive inverses. So we don't need to waste our time drawing a number line on number 4. It mightn't hurt on number 5 to draw a number line, but first, we're not going to work that problem. Because number 5, they're telling us to do what, Corey? On number 5? They're telling us to subtract. We don't do that here. We don't subtract, class. We add the inverse. So, Corey, the first thing I'm going to do here, when they say to subtract a positive 9, no. We're going to adding a negative 9. So on our number line, class, we would start here at negative 3. And if I go backward, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, where would I end up, Corey? Negative 12. How many had negative 12 for number 5? How many had positive 6? You didn't notice they were telling you to subtract. Yeah, be careful there. Number 6 is a similar thing here. They're telling us to subtract a negative 2. And then we don't do that here. We don't subtract. We
add the inverse.
Well, I was asking Ben, but you're right. We add the inverse. So we're going to change it to adding a positive 2. Well, Ben, if we start all the way back here at negative 7, and we now add a positive 2, so we go that way, 1, 2. Where would we be if we added a positive 2?
Negative 5.
Negative 5. How many at negative 5 for number 6? Number 7, we don't subtract 9 minus positive 5. No. We're going to change this, Griffin. We're going to add the inverse. We're going to make this say 9
Plus negative 5.
There we go. So if we started all the way up here at 9, and we add a negative, which direction do you go, Griffin?
Left.
Left. So we go left, 1, 2, 3, 4, 5. Where would we be if we went this way 5 places?
4.
We'd be at 4. How many at positive 4? Your answer for number 7. Number 8. What did you get for your answer on that one, Joel? Number 8?
3.
Positive 3 is correct when you change it to adding a positive 9. Number 9. There's 2 ways you can look at this, but the way they want you to look at it is 12 minus 3. What sign technically does the 3 have, class?
Positive.
Technically it's positive, isn't it? It doesn't say positive, but if you don't see a sign, it's positive. And we don't want to subtract a positive 3, class. We want to add a negative 3. So we'd start at 12 and boink, backward 3 this way. What would we get, Elaine?
9.
Positive 9. What about number 10? Again, it says negative 5 minus 7. Again, technically, class, this is a positive 7. But we're going to change this to adding a negative 7. And so negative 5 plus negative 7 would give us what, Bryson? Number 10?
12.
Negative 12. There we go. If you start at negative 5 and go back 7 places, you're going to end up at negative 12. There we go. On number 11, are those additive inverses? Well, they are, but we're not adding them, are we? It says negative 4 minus 4. Where again, technically, class, this is a positive 4. But if you add additive inverses, they cancel. They're not telling me to add. They're trying to get me to subtract, and we don't do that. We don't subtract, Jalen. We
Add negative 4.
we add negative 4. We add the inverse. And if you start at negative 4 and you go backward 1, 2, 3, 4, you're going to wind up at negative 8. Our answer for number 11. And then number 12. I mean, let's be real. 12 minus 10. Okay, we could do that in our head class. 2. Did anyone go 12 for 12 on that first section? How many of you just missed 1 or 2? Just missed 1 or 2. Are there any of them you say, Mr. Dasky, I did it all on the number line, I was real careful, and I don't understand how I missed number blank. Michael?
It's not like a number, it's just a question. So when we subtract, we add the inverse, but when we add, we don't.
Right, addition is just addition, right? But subtraction, we change it to adding the inverse. That way, instead of having to memorize, okay, subtraction, we go this way, adding, we go this way. When you add a positive this way and you add a negative, it's that way. But if you subtract a positive, it's that way, subtract a negative, right? We want to keep things simple because we're lazy, right? So we try to simplify our lives. So we say, you know what? If it says subtract, no. We're going to add the inverse. And that way, we only have to memorize one thing. When you add a positive, you add a negative, and that's easy for me to remember. Does that make sense? All right, good question. Good. Other questions? Well, let's take a look at number 13. What property is being illustrated here on number 13? Corey? Associative property. They are equal to each other. Both of those would equal 14, no matter which way you added them up. What about number 14? What do we have here, Jalen?
No property.
No property. What property were they trying to get you to write, Jalen?
Associative.
They were trying to get you to write associative, but no. It has to be all addition or all multiplication to rearrange stuff like that. You can't just, no. The two sides become what, 36 on one side and 30 on the other? They're not equal to each other. No property used there. What about number 15? What do we got going on there, Joel?
No property.
Well, both sides equal 27, don't they? And if they both equal 27, there's got to be some property being used because they are equal, Kirsten.
Distributive.
Could you see the distributive property there, Joel? They took the 3 times the 8 and the 3 times the 1. So they distributed the 3 to both the 8 and the 1. Do you see it now? All right. Questions on 13 through 15. Top of the next page, find the answers. This just goes back some basic review from a long time ago. What did you get when you added 2 2/3 plus 16 3/5? We needed a common denominator there, Bryson. 19 4/15. Good, you should change it. To get 2 10/15 plus 16 9/15, end up initially getting 18 19/15. But of course we simplified down as Bryson did, 19 4/15. What about letter B? When we multiply those mixed numbers together, of course we change in improper fractions and all that first. What do we end up with there, Joel?
8.
8 is correct. All it cancels out and just give you an 8 for your answer. Does anyone need to see either of those worked? I talked through them. Do we need to see them worked out? All right, number 17, converting to decimals. Woo! It's been a while. 1/6. How many had to look it up? How many were too lazy to look it up? You figured it'd be faster just to divide it out. 1 divided by 6. All right. What did you get for your decimal answer, though, on that, Michael?
16.6 repeat, or I'm pretty sure you could write.
Well, you made it a percent. 16.6 repeating percent. They just wanted the decimal, so just...
Point 16 repeating.
0.16 repeating, where the 6 repeats. 0.16, and remember, just a line over the 6. 0.16 repeating. It's been a while. 70%. Boing, boing. What do we get for that percent, Ben?
0.7.
0.7. How about, 3/4%, Elaine?
0.0075.
Good. 0.75%, and then boink, boink, 2 places, 0.0075. What about 2/9? This one we should remember, Bryson. 0.2 repeating. Remember, anything over 9 is itself repeating, other than 9/9. That's just one. What do we put in the blank? Less than, greater than, or equal to? Now, 18A, what would go in the blank, Griffin?
Equal to.
Equal to. What about letter B, Griffin?
Greater than.
Now, -10 is greater than -100, but the
Less
absolute value of -10 is less than the absolute value of -100. How about letter C, Griffin?
Greater than.
Greater than, and letter D?
Less than.
Less than. Good on those. All right, questions on the homework. Take a couple moments, if you would, and do the review on page 108. Do page 108, the review 33 to 37. Page 108, the review 33 to 37. There's your seats. Finish. Just sit there. All the way to 37. Whole review section. Finished. Good, Elaine. 40. Joel finished. Good. Just a little bit longer. Finished with all of them or thinking? Sit nice and tall, Lori. Griffin Bryson finished. All right, good, Jalen. For sake of time, pencils down. Even if you're not finished, most of us are. I've got some candy here for the first person who finished with all the right answers. Now, Michael was done first. If he's perfect, he gets the candy. If not, we'll go to the other people in the order that they finished. So, Michael, letter A on number 33, are they equal or are they not, first of all?
Not equal.
20 equals 20. So let's see, second person done was Elaine. And Elaine, did you have an equal sign in that blank?
Yes.
All right, what property justifies that?
Distributive.
Distributive. How about letter B, equal or unequal?
Equal.
Equal, what property is that?
Commutative.
Commutative, they just flipped the order. How about letter C?
Not equal.
Not equal, yeah, there's no property there. They were trying to use the associative, but we should write no property in the blank and put a not equal. 7 does not equal 9. Okay, so that's not true. All right, let's stay with Elaine as we go to number 34. You had a subtraction problem?
5 and 5/7.
Ooh, that is not right. Super close. Corey, I think you were third. Are you perfect, first of all, on number 33? What did you get on 34A?
5 and 9 14.
5 and 9 14ths. I think you had 5 and 10 14ths. 5 and 9 14ths is correct. All right, so Corey, the next one was a division problem. What did you get on letter B?
10 over 21.
10 21st is correct. Great job. You make it a 4/3 divided by 14/5, then it becomes 4/3 times 5 14ths. Reduce it down from there. Number 35, Corey, letter A becomes?
0.00825.
Oh, a couple issues there. All right, so third, I believe, or fourth rather, would have been Joel. Joel, what did you get? Well, first of all, Joel, are you perfect so far?
No.
You are not. Okay, fifth would have been Ben. Ben, are you perfect so far?
I missed A.
Okay, so let's see. Then no, she finished just after that. I think Griffin, Bryson, Jalen are the three left. Okay, so no, not perfect so far? Yes, okay, so what did you get for 35A?
35A.00125.
Ooh, all right, Jalen, you're the last hope here for Candy. What did you get for 35A?
0.875.
Just 0.875. It's not a percent, so we didn't need to boink and get 0.00, and it's 875, not 825. All right, let's stay with Jalen. Letter B.
0.02.
0.02 when we boink, careful on C.
0.046.
Excellent job, 0.046, and letter D.
0.6.
Oh, she's so
Can I
close.
say it?
What is it, Griffin?
0.6 repeating.
0.6 repeating. Candy's off the table.
Oh,
All right.
Twix.
It was a Twix.
Twix.
All right. Number 36.
Twix.
Ben, what did you get for 36A?
36. 5.
5. 36B, Corey.
2.
36C, Jalen.
0.7.
36D, Joel.
6.
6. Number 37. How did you rearrange those numbers if they were going from least to greatest? Bryson?
-8, -4, 3.2, and 6/4.
If it had been a -8, you'd be exactly right. But it was the absolute value of -8, which is what?
8.
So suddenly that actually becomes the biggest instead of the smallest. So otherwise you were right. -4, 3.2, 6 4/5, and then the absolute value of -8 would have been the last one. Questions on that review? Questions on adding signed numbers, questions on adding the inverse, questions on those three properties. Clear desk, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. You could feel it coming, couldn't you?
Yeah.
Like it's been a long time since I don't think we've had a quiz this whole quarter yet. So
Nope.
yeah, we are long overdue to have one here. Should be a pretty straightforward one for you. Just be careful, don't make a stupid mistake and cost you, but I think we should be good with this content here. Clean sheet of paper as a cover sheet and a pencil, everything else off your desks.
You make that 37 times you're about to take your quiz.
Yeah, you know. Hey, there's one. Just use this one. We can use that. It'll be fine. All right. When you get your quiz, put your first and last name in the name spot. Today's date in the date spot. And today is 1/16/24. 1/16/24 today's date. Make sure you pass those back, Ben.
Oh.
There you go. Keep the top one, pass the others back. There we go. All right. First last name in the name spot. Today's date in the date spot, 1/16/24. Let's take a look at the quiz together very quickly. Numbers 1 through 3, are those statements true or are they false? If they're false, fix them. If they're true, just write true. For numbers 4 through 7, you are not actually working these. Let me say that again. 4 through 7, I'm not looking for an answer. Literally, all you're doing is rewriting 4 through 7 the way we would do them, because we don't do subtraction here, right? So just in the blank, rewrite it as an addition problem. Don't actually solve anything. Everyone got that? For numbers 8 through 10, they've given you a number line. Those you're actually going to do whatever it says to do. Those you're actually going to get an answer. All right, use your blank page as a cover sheet, and you may begin. When you finish, turn your paper over, just sit quietly. Bless you. Just another minute or so to be putting down final answers. Looks like everyone here is finished. If you're watching on video, you need a little bit more time. You can pause the video. In here, if you would pass your papers to the front, just pass the paper to the person in front of you all the way up to the front of the room. We'll take a look at these tomorrow, off camera, of course. And let's go ahead and get into our next concept. If you would, open your textbooks up to page 109. So once you've passed your quiz forward, open up to page 109 in your textbooks. And let's be honest, this whole number line jazz has been a little annoying, right? I don't like, especially if I have to draw the number line. Like, if they give me the number line, okay, that's not too bad. If I have to draw my own number line, there's got to be an easier way, because mathematicians are lazy. And I think we can make some observations here. If you look in the textbook here on page 109, they've got a 2 plus 3. Well, for one thing, we already know 2 plus 3. I don't need a number line for that, because 2 plus 3 equals 5. But think about this. Think about this. If it's a positive 2 plus a positive 3, you realize positive 2, if you were using the number line, is already on this side of 0 anyway, right? And when you add more positivity to it, it just keeps moving it further from 0, correct? Right? So when you add two positives together, you're already starting on this side. You add more positive, it just goes further that way. The same thing would be true, though, if you had a negative 2 and added a negative 3, except the other direction, right? You would already be at negative 2, the book shows, and then you add negative 1, 2, 3. You're just going more negative. Does that make sense? Positive plus more positive obviously is going to equal a big positive. Negative plus more negative is really more negative, right? So really all we're doing in both cases, class, is we're just saying, hey, what's 2 plus 3? 5, and we're keeping the positive sign. What's 2 plus 3? 5, and here we're keeping the negative sign. So we have this rule: if you're adding numbers and the signs match, just add up the numbers, if you will, add up their absolute values, and keep whatever sign they happen to have. Does that make sense? So that should be pretty straightforward. So looking at the example problem at the bottom of 109, they have a negative 5 minus 7. Of course, we know we're going to change this to negative 5 plus negative 7. Well, again, without a number line, I'm already at negative 5, and I go more negative by 7. Plus, where's that going to wind up? Negative 12. Because 5 plus 7 is 12, and we just stick the negative sign on. Make sense? We're going to say this way: if the signs are the same, add and keep the sign. If the signs are the same, add and keep the sign. But what if the signs are different? Look at the next page. What if you have different signs? For instance, they give us 2 plus negative 7. Well, I mean, that changes things a bit, doesn't it? You're starting at a positive 2, and you're going all the way 7 places negatively, right? Well, the first 2 places take you to 0, right? And then you have how many more places to go? If you're going to travel 7, go 1, 2. How many do we still have to go, class? 5 more. 1, 2, 3, 4, 5. Well, obviously that means that's going to put us at negative 5, right? Think about what we're technically doing here. Mentally, we could almost think of this class as like 7 minus 2 is 5. But we're keeping the bigger sign. Which sign wins, the positive or the negative here? The negative wins because it's more negative than this is positive. Does that make sense? For instance, it's like 2 steps forward and 7 steps backward. Well, you took more backward steps, you're going to end up backward. Does that make sense?
Yes.
Right? Okay, so in that, and we would do the same thing, by the way, if it is positive 7 plus negative 2. Well, if you take 7 steps forward, class, and only 2 backward, in the net, you still moved forward, didn't you? You moved forward how far? 7 forward, 2 backward?
5.
Forward, 5. Anytime the signs are different from each other, we're practically speaking 7 minus 2, 5, and then whichever sign wins, quote unquote, is the sign that we keep. Here the negative sign wins, so we'll keep it. Here the positive sign wins, so we'll keep that. Here's the rules I want you to write down in the side margin, if you would, of your book. We're going to memorize these rules and use this rather than the number line. This is going to be much, much more efficient for us. First rule is what we said a moment ago. Write this down if you would. If the signs are the same, add and keep the sign. If the signs are the same, add and keep the sign. If the signs are the same, add and keep the sign. And you see a couple of illustrations on the poster there, right? Positive 2 plus positive 4 is positive 6. Now, the way I've written this here is the way I actually teach it to my older students. I treat them this. If you see 2 signed numbers, assume there's a plus in between them. Negative 7 plus negative 5 is negative 12. Okay? But if we wanted to call that subtraction, we could change it to adding the inverse and all that jazz. That's if the signs are the same. If they match, add them up. Match, add them up, keep the positive, keep the negative. Next rule to write down, if the signs are different, subtract. And choose the sign of the greater absolute value. Subtract and choose the sign of the greater absolute value. This frees us up from ever using a number line again to add signed numbers, which is nice because I don't like number lines. Waste of time. Signs are different, subtract, choose the sign of the greater absolute value. So here, the signs are different. So 9 minus 3 gives us 6. Which sign wins, class? The positive, the 9's sign. Here, 7 minus 2 is 5. But the negative sign wins, so we keep the negative. Whichever sign wins is the sign we keep. What about additive inverses? Is there a winner?
No.
No. So there is no sign to keep, because 0 is not positive or negative, right? If you add a negative 8 plus a positive 8. Well, the signs are different, so we would subtract 0, keep the sign of the winner, the greater absolute value. They're the same, so you don't keep a sign at all, you just say 0. Look at the examples in your book there on page 110. Example 3.3b. 8 plus negative 5. Are the signs the same or different, class? Different. So we subtract 8 minus 5 is? 3. Which sign do we keep on letter A, the positive or the negative? The sign of the 8, which was positive. So we say positive 3, or because we're lazy, 3. Look at the next one, negative 9, positive 3. Well, do we add or subtract? Subtract. Now again, we don't do subtraction as written, but mentally 9 minus 3 is 6. But which sign do we keep? The negative, the one of the 9, right? So negative 6, the answer there. Does that make sense? Look across the page now, page 111. Number 1, are the signs the same or different, class?
Same.
Same. So do we add or subtract? Add. If the signs are the same, class, say this with me. If the signs are the same, add and keep the sign. So number 1, the signs are the same. Do we add or subtract? Add. 3 plus 2 is? 5. And then we keep the sign. Well, what sign do the 3 and 2 both have?
Positive.
Positive. But it's understood positive. So if you want to write positive 5, you can. If you want to just write 5, you can. Look at number 2. Are the signs the same or different?
Same.
Same. Do we add or subtract?
Subtract. Whoa.
If they're the same, if the signs are the same, class, add and keep the sign. Say that again. If the signs are the same, add and keep the sign. So number 2, do we add or subtract? Add, because they're the same. What's 6 plus 4?
Negative.
10, and now we keep the sign, so we keep the negative. So our answer is negative 10. Look at number 3. Signs are same, so we add to get 20, and then we keep the negative. Negative 20. Seem easy? Look at the next one. Number 4. Signs are the same, so we add to get 9, and technically we keep the positive, but we're lazy, so we don't write it. Look at number 5. Now the signs are different. So we're supposed to subtract and choose the sign of the greater absolute value. So on number 5, we subtract 10 minus 2, 8. And when we choose which sign we're going to keep, we choose the winner. Who's the winner in number 5, class?
10.
The 10. So we keep the positive. There we go. So when I say who's the winner, either answer positive or negative. In number 5, the positive is the winner. So we'll say positive 8. Look at number 6. Signs are different, so we technically subtract. 6 minus 5 is 1. But which sign do we keep? Negative, because the negative wins. Look at number 7. Signs are?
Not the same.
So we would say they're different. There we go. Let's go with what's on the poster. Signs are different, so we subtract. 9 minus 4 is 5, but we keep the negative. Okay, look at number 8. Signs are different, so we subtract to get 4, and then we keep what sign?
Positive.
The positive, or we just say 4. Do we see how the signs work here? If they match, add them up, keep the sign. If they're different, subtract the values, and then whichever sign wins, keep that one. All right, I want you to do 9 to 16. Don't go any further, just 9 through 16. Pencil down when you've got those 8 problems finished. Don't rush. Think through your steps. And the reason this works is because they're both positive, both negative. They're working together in the same direction to make a bigger value further from 0. They're in opposite directions. They're going against each other, so we subtract. We keep the sign of that which wins, so to speak. Stop when you get to number 16. number 9, I could say signs are different, so I subtract and keep the sign of the greater absolute value, or the winner. But I could just look and be like, hey, those are additive inverses. My answer is 0. Number 10, the signs are?
Same.
Ooh, on number 10, pay attention, follow along. The signs are the same. So class, I'm going to add them up. And 25 and 39 adds up to 64. But I'm going to keep the negative. So my answer should be negative 64. Number 11, signs are? Same. So I'm going to once again add to get 152 and keep the negative 152. Number 12, signs are? Different. So I have to subtract 215 minus 100 is 115. But I got to keep the sign of the winner, so class, I'm going to keep negative 115 for number 12. How many perfect on that row? All right, let's take a look at number 13. Griffin, signs the same or different?
Different.
So do I add or subtract?
Subtract.
8 minus 5 is?
3.
3. And which sign do we keep? Positive or negative?
Negative.
Negative. Number 14, signs the same or different? Kirsten?
Different.
Different. So I'm going to add or subtract?
Subtract.
What's 37 minus 15?
I didn't subtract that.
Okay. What is 37 minus 15?
40, not 42, 22.
22. And then which sign do we keep, Kirsten?
Positive.
Positive 22. Number 15, signs same or different, class? Different. So we're going to subtract. What do we get when we subtract, Jalen? 21. Which sign do we keep?
Positive.
Positive 21. And number 16, class, those are additive inverses, so my answer is just 0. All right. Was anyone perfect 9 to 16? How many say, this was my first time trying them, and I had a little bit of trouble here? Any questions on those? Now look at number 17, class. It's not even an addition problem. It's a
Subtraction.
At least that's what they printed, but that's not what we gonna do. So on number 17, we're gonna change it. It says negative 9 minus positive 10, but we don't subtract. If it says subtract, class, we add the inverse. Now, back to those two rules. Are the signs the same or different? Same. Do we add or subtract? Add. What's 9 plus 10?
9.
What sign do we use? And we just keep the negative sign. Look at the next one. Do it with me. We got a 15 minus positive 15. We don't subtract, class. We add the inverse. Oh. But 15 and negative 15, class, they're going to give me 0. They just cancel. That was easy. Look at the next one. Says negative 19 minus positive 10. We don't do that, class. We add the inverse. You're doing this in your book with me right now. Change it to adding the inverse. Now, are the signs the same or different? Same. So we add to get
29.
and then we keep the negative. Don't judge the signs until you've added the inverse. Does that make sense? If it's subtraction. Now, on 1 through 16, we didn't have to add any inverse, right? Because all of those were already addition. If they give the subtraction, add the inverse, and go right back to these same two rules. Look at the next one, number 20. It says 70 minus positive 16. Well, no. We don't do this, class. We add the inverse. Now, signs the same or different? Different. So we're going to subtract. Ooh, 70 minus 16?
Negative 54.
Well, just call the number 54. Now, what sign do we keep, class? Or what sign do we use? The positive, because the positive wins. Positive is bigger than negative in this case. It's absolute value technically greater. There's more positive than there is negative. Let's put it that way. And we keep the positive 54 on this one. Look at the next one, number 21. It says 19 minus negative 4. No, Ben, we're going to rewrite this as 19
Plus positive.
Signs the same or different, class? Same. So we add to get
23.
And technically we keep what sign?
Positive.
Positive. I'm just too lazy to write it. Look at the next one. We got is 9 minus negative 7. No. We're going to change this, Jalen.
9 plus positive 7.
Signs the same or different, class? Same. So we're going to get
16.
16. And then technically positive 16. Look at the next one. We got a 10 plus negative 7. Hey, do we need to add the inverse, class? No. It's already an addition problem. So we save ourselves a step. Signs the same or different? Different. So we subtract to get.
3.
And what sign?
Positive.
Positive, we can leave it understood. We could write it if you want to write the positive, you can. Look at number 24. We got a -6 minus -4. Oh man, back to subtraction. They say, but we don't subtract. We add the inverse. So Bryson, we're going to rewrite this.
-6 plus positive 4.
Okay, now class, signs the same or different?
So it's
Different.
Different, so we're going to subtract. What's 6 minus 4? 2, and then we keep the
Negative.
sign because the negative wins. Do we see how to approach it even if they give us subtraction? I want you now to do numbers 25 to 36. 25 to 36. Finish out the page. 25 to 36. As I mentioned, we're going to go a little past the bell because of our technical difficulties here. If it's addition, just stick to the rules. If it's subtraction, add the inverse and stick to the rules. For sake of time, pencils down. Even if you didn't finish all of them, let's go over the ones we did get done, though. Number 25, let's start with Elaine. What was your answer?
25.
On number 25, what was your answer?
18.
Positive 18 is correct. Change it to -1 plus positive 19. Signs are different. Subtract, keep the sign of the greater. Number 26, Joel. Number 26, what was your answer?
I did it backwards. I went this way.
Kirsten, what was your answer on number 26?
Positive 20.
Positive 20. Subtract, keep the sign of the greater absolute value. Number 27, Ben, what was your answer?
-19.
Negative 19. Add and keep the sign. Number 28, Griffin.
-2.
Negative 2. Subtract, keep the sign of the greater absolute value. Number 29, class.
0.
0. Number 30, Michael.
Positive 14.
Positive 14. Good. Add the inverse. Make it -16 plus positive 30. Then the signs are different. Subtract, keep the sign of the greater. You get positive 14. Number 31, Jalen. Oh, be so careful. If that had been plus -18, you'd be right, but it's minus -18, so when we add the inverse, it's 18 plus positive 18. Add and keep the sign, Joel.
36.
Positive 36. Number 32, back to Jalen. I'm sorry?
192.
Are the signs the same or different on 32? They're different, so we need to subtract. 100 minus 92 is 100 minus 92. Well, just 8, right? Just 8. And then we would keep the sign of the greater. So on number 32, we would keep which sign?
Positive.
Positive 8 would be correct. Let me stay with you on 33, Jalen. This one we have to rewrite as adding the inverse as well. How do we rewrite 33, Jalen?
Negative 10 plus positive 9.
Good. And what do we get for that answer? -1. Good. Subtract, keep the sign of the greater absolute value. 34, Corey?
31.
Positive 31. Add it to make it a plus positive 7. Add and keep the sign 31. Number 35, what do we get, Bryson?
0.
Oh, be so careful. You fell into the trap that Jalen fell into. We have to rewrite that as negative 20.
Plus, negative 4.
Ah, now the signs are the same. Add and keep the sign.
No, 40.
Negative 40 should have been our answer there for redemption. Number 36, Bryson.
Positive 12.
Sign's different, so here we got to subtract 11 minus 1,
It's
10, and then keep which sign?
It's positive.
Positive 10. Should have been our answer there. Was anyone perfect 12 for 12 on those? Anyone miss just 1 or 2? Are there any questions? I kind of talked through each of them. Are there any questions on any of those? All right, it's a new way of thinking, right? So that's okay. I expect some struggles early. Homework tonight give you a chance to work through it and think through your rules carefully. Page 113, do numbers 1 to 24. Page 113, do numbers 1 to 24. All right, have a wonderful rest of your day, and you are dismissed.